Welcome everyone to our free GRE Quant webinar. Whether you're here for the first time or have been to one of our webinars before, thanks for joining us. My name is Andrew and I'm one of the student success advisors here at Ready4. I consult with students, connecting them with courses that best suit their needs, and I'm happy to be able to host today's webinar and give you all a chance to meet one of our talented instructors. So let's get started. A couple of things to know before we begin. The first thing, you're all muted. So depending on where you are, anything you say out loud might look crazy to those around you, but it won't get our attention. Instead, take a minute to find the question box. This is going to be an important tool for you today. Any questions you have about the content of today's lesson, about the GRE in general, or about our courses, you can type them right into that question box and we'll either respond to you directly or during our Q&A session at the end. Also, when it's time to cast your vote, as we're doing in-class examples, you're going to type those right into the question box as well. We'll be sharing these slides, answer explanations, and a handout exploring our services at the end, so don't forget to download those as well. Finally, this session is being recorded, so be on the lookout for that follow-up email after class if you'd like to view the recording or the handouts, especially if you're tuning in from a mobile device. Here's what we're going to cover today. I'll start by telling you a little bit about what we do here at Ready4. Then I'll pass things off so you can see one of our experts in action. While these webinars aren't going to teach you everything you need to know for the exam, they provide a solid intro to the tests and a chance to meet one of our instructors and get an idea of what our courses are like. I promise that whatever stage you're at in your GRE prep, you're going to take away from some strategies that you can apply now and continue to improve on throughout the rest of your practice. If you enjoy the session, stay to the end and I'll jump back on and provide some more information about our courses. We even have a special surprise to say thanks for being here. That's going to be at the very end of the session. All right, a little bit about us. Ready4 was started out of MIT back in 2013, and our goal ever since has been to make test prep more affordable and more accessible for students. That's why we offer a number of different prep options based on your needs and your budget as you prepare for the exam, ranging from our top-ranked practice tools designed to measure and adapt your performance so that you're better, it's really better than any book, to our fully immersive prep courses, whether live or on demand with the best instructors in the industry. We're providing a flexible, mobile-led learning experience to fit the needs of any student, regardless of your location and your background. But I'll talk a little bit more about our services at the end. I want to introduce our instructors so we can begin the lesson. So today's session will be led by Richard. Richard has a 99 percentile score on the GRE, including a perfect quant score, and 15 years of experience preparing students for the test. Students love Richard's straightforward approach and the way he methodically breaks down problems. He has a ton of content knowledge, and you're going to see that in today's session. All right, now I'm going to pass things off to Richard, but remember, if there's anything I can help with, I'm right at the other end of that question box. Good luck, everybody.
All right, well, thanks for that introduction. Let me share my screen with you guys. I am indeed Richard. I'm from Indiana originally, have a bachelor's in physics and mathematics from Indiana University. Also have a master's in applied physics from Stanford. Lived in Asia for about 15 years, teaching in Thailand and Bangkok, where I taught SAT, SAT2, SSAT, GMAT, GRE, LSAT, MCAT, kind of the whole alphabet soup of standardized tests. And did I mention TOEFL? A lot of TOEFL too. So I do have an MBA as well, which I earned at Assumption University in Thailand. My concentration is in finance. And I think the slides already says that I've passed all 3 levels of the CPA program and hope to earn my CFA charter soon. So in any case, we're here to talk about GRE today. So while I'm getting set up, why don't you guys go ahead and introduce yourselves in the question box. I definitely like to know who I'm talking to. So please feel free to tell us your name, where you're located, experiences with the GRE, if any, or anything else that's interesting about yourself or where you are. In the past, I've had people from all over the world, Kenya, the Netherlands, Singapore, Taiwan, Colombia, you kind of name it. We basically had it. And so, oh, cool. So we've got a couple of people checking in already. So Flagstaff, Arizona, awesome. Nigeria, cool. So yeah, so welcome to class. And it's one of the reasons why I'm really excited to teach for Ready for GMAT is I do get the chance to go online and meet people, from all over the world and get to teach them, share my knowledge with them. And I really appreciate that. So do keep introducing yourselves in the question box. I do enjoy seeing those. So the GRE, a longer test, 3 hours and 45 minutes long. Basically, you can take it any day of the week. Costs $205, as you know. So you've got 6 sections: writing, 2 math sections, 2 verbal sections, and also a experimental section. So the analytical writing section gives you 2 essays, essentially, an analysis of an issue, which is sort of an agree-disagree type of essay, and analysis of an argument where you're basically trying to break down somebody else's opinion instead of giving your own opinion. And that's scored from a range of 0 to 6. Then you have the verbal reasoning and quantitative reasoning sections. So 20 questions each for 30 minutes, actually 35 minutes for math. And then the range is from 130 to 170. So the average in theory should be around 150. It's slightly higher for math, and I think slightly lower for verbal. Then you also have an experimental section, which will be either math or verbal, but you won't know which one until you finish the test. You can count them up, how many you had. Okay. So I'm just checking out your stories here. I've got more than one person from Nigeria today. That's or 3. Wow, that's quite a lot. Okay, great, fantastic. Yeah, so I really enjoyed that. In any case, so GRE scoring, it is adaptive. So it's based not just on the number of answers that you get correct, although that would be normal for most tests. It's also based on the difficulty level of the questions. So in an adaptive test, you want to get to harder level questions. The idea is that with adaptive testing, they're trying to match the level of difficulty with your ability level. So when they give you a question that's not too easy, you're going to get it right for sure. If they give you a question that's too hard, you're going to get it wrong for sure. They want to get a question that's kind of just about right, where it's not too easy, not too hard, and you have kind of a 50-50 chance of getting it right. And when it finds that difficulty level, that level is going to be your ability level, and therefore your score. They also do care about the total number of questions that you answer. Make sure you do not run out of time at the end of a section. If you leave questions blank at the end, there is a pretty steep penalty. It's basically just a pure pro rating. So I think I've already mentioned the first point. So make sure you leave time at the end of the section. You do need to answer every question. There is no guessing penalty for answering questions wrong, so it is to your advantage to guess every single time. You need to answer every question, basically. Don't stress out too much about the what you think is the difficulty level. This is something that's actually really overrated. Some people think if they get a hard question, that means they're doing really well. If they get an easy question, it means they must have screwed up something and got something wrong. And the answer is you don't actually know that. One reason, of course, that what is considered easy or difficult is totally subjective. You and I might do the same question, and one of us might think it's easy, and the other one might think it's hard, even though it's the same question. So that's not necessarily a relatively useful guide. Well, of course, what's more important is using your strategies and guessing effectively and trying to get a high percentage on your accuracy. And then, of course, practicing with the right tools and content. So, of course, there's the Ready For app. Then you have these free webinars like we have today. And then you also have the full GRE course, which we will talk about more during the Q&A session after I've given my little mini lesson. And then, of course, there's also the official materials from the GRE, which is straight from the ETS, the Evil Test Service. Okay. So that's my quick look at the GRE. So I just kind of keep an eye on the question box. Interesting. Okay. So let's do some examples together here. And I want to point out that your studying for GRE has kind of divided on 2 levels. One level is just pure knowledge. you need to know the rules of addition, subtraction, multiplication, division. You have to know the rules for decimals and fractions and percentages and that kind of stuff. And maybe you learn that stuff when you're in school. Maybe you still use it every day if you're an engineer, or maybe you've forgotten it because you just haven't used that math in 5-10 years or something. But either way, you want to get up to speed on that stuff pretty quickly and relearn it or become familiar with it again. And that's kind of number one goal for the class, so just make sure you know all the basics and have all the fundamental skills that you're supposed to have. The second level is the strategy level. So looking at the way the question is designed, looking at the different answer choices, reasoning about what answers may be correct or might be incorrect based on kind of features or indicators in the problem, and kind of working with what you know to make strategic guesses and apply a technique that will give you the correct answer in a short period of time. So there's a lot of questions you can get right if you have an infinite amount of time and you can just sit down all day calculating. But with a time limit, you got to make sure you have an effective approach, that you're being strategic, and that you're using some kind of reasoning process to determine which answer is the correct answer. Okay. And I think overall with GRE, you want to make sure that you're focused on trying to find the answer choice, which would be A, B, C, or D, for instance, rather than trying to figure out what the number is. Okay, so the number is useful, but the number is only useful insofar as it helps you pick the correct answer choice. So this comes from a lesson on arithmetic. So basically, we get back into some of the basics about place values, digits, the order of operations, also some stuff about exponents and roots, some stuff with prime numbers, also fraction exponents we're going to talk about, and negative exponents, although I don't see a place to highlight it. Roots, anyway, but we're going to have negative exponents today too. So a little bit of all the good stuff in arithmetic. So place value system, make sure you know the names of the places compared to the decimal place. So the most important place, of course, is the units place. Places to the left that get bigger and increase in size are the tens, hundreds, thousands. Places to the right that get smaller use the THS, so tenths, hundredths, thousandths, and so on. And so one common activity that you need to do, of course, when you talk about the places is know how to do rounding. So you guys probably remember this for sure. When you want to round someplace, what you do is you look at this number and you compare whether it's more than 5 or less than 5. So like for instance here, let's see if I can get my little pen going. Aha, yes, we can. So because this is less than 5, then what it does is it means we just stop right here. We don't have to make any changes. We just cut these numbers out and we're fine, 9365. On the other hand, if the number is more than 5, then you need to round up. But you also have to realize what place they're asking you to round to. So the nearest 10th digit is actually this place. So what we're going to do is we're going to cut off here, and we're going to look at this 5 and say, oh, that's greater than or equal to 5. So that means we've got to round this number up. And so we're going to wind up with something like this, 7422.8. Okay. And yes, there's a little decimal there. I know it's actually really small. I'll try to make a nice fat dot for you guys. And so that's a pretty typical, mechanic. They might ask you to use it in a more complicated way on the GRE, of course, like this. So here they give you a number. They ask you to round. They give you a formula. They want you to find the value of C minus C double dot. So I'm going to back out here for just a moment. I'm going to give you guys about 90 seconds to work the question. I'll turn the camera off so you can go full screen and see it a little bit larger. And when you're done, go ahead and type your answer into the question box. Okay. So taking a look at the questions as they're coming in. So make sure you enter the answer as a letter. The number is not the answer, right? The answer is either A, B, C, D, or E. And going down the list, I see the majority has picked B, although I see a few C's and D's in there. Actually, I also see an E in there. Okay, so making sure that you reason through the question correctly. So one thing to think about, of course, is the fact that the value, the C double dot value, is the value that you get after rounding. So if you are going to be rounding, if you're going to round up, for instance, then what happens is the second number will be bigger than the first number, which means you're actually going to wind up getting a negative answer, right? Versus if you think you're going to be rounding down, then you should get a positive answer, because if you're rounding down, this will be a smaller number. Okay, so are we rounding up or rounding down? Well, we're rounding to the nearest thousandth place, which is this place right here. So the original number is going to be 0.00465. But then if we're rounding, you definitely can see that this is going to be bigger than 5. So this is going to be rounding up. And so already we know that we should have a negative answer, because we're rounding up. When you subtract a bigger number, you get a negative result. So the new number after rounding will be 0.005. And we'll take the difference between those. So the difference should be 0.00035 with a net minus sign. And the correct answer is choice B. Yeah, so C. Just taking a look at some of the other choices here for a second. Yeah, if you're going to do this, make sure you're very careful about lining up the decimal. You really got to do that. I know it's a little small on the screen because it's just a dot, but I'll try to make it bigger. You know, when you do these calculations, it's very important you know which place you're in or which column you're in. If you just shift the decimal one spot too far to the right or too far to the left, you can get trapped by a wrong answer very easily. So make sure you got that accurately lined up. Okay, so the other format for questions in GRE is called quantitative comparison. So the idea of quantitative comparison is they give you two columns, column A and column B. And what you're being asked to decide is which one of these two things is bigger, or if they're equal, right? So you only have 4 answers here. So choice A would be that A is always greater than B. Choice B is that quantity B is always bigger than quantity A. Choice C says that the two are equal to each other, but they have to always be equal if you pick choice C. And then D says it cannot be determined. In other words, it can change. That sometimes A is bigger, or sometimes B is bigger, or sometimes they're equal. So D is really the answer that means sometimes, or sometimes it can change. So I'm going to give you guys 90 seconds again, and back out here, and then we'll go through the solution together. So again, please type your answer in the question box. Okay, I hope you guys enjoyed the little beat there. So yeah, so please be typing your answers in. Okay, so I got, I think the majority of, looks like the majority is going for B, some D though. Okay. Well, so a couple issues. Of the the four choices, the one answer that can never be right, at least for this specific question, is choice D, because there's no variables in the problem. Now, you may or may not know this number, or you may or may not have calculated all the way to the 28th digit to the right. But when you get there, it will definitely be a number, okay? And that number will either be greater than, less than, or equal to 1. So for sure, it's going to be a definite something, so D can't be the right answer. Other thing to notice is just in general, if you look at all the different digits, so these are the possibilities. Notice that the vast majority of the digits are greater than 1, right? So if I was guessing, I probably would be tempted to guess choice B, just because it's the one that's the most likely. Basically everything is bigger than 1, except for 1 itself and maybe 0. So I'd be strongly tempted to pick B on a question like this, no matter what. But yeah, you can definitely do this calculation. So 1 over 22. There's a couple of different ways you can do it. One way is just straight up long division. And if you look for a number like 4, I think will give you 88. And then 4 times 22 is 88. If you subtract, you get 12. Add another place, and get 120. Now you can take 5 into that and get 110. And then this is actually going to be enough information for us, because if I take 5 times 22 and get 110, the next time I subtract, I'll get 10. If I add another 0, then basically we're back up at the original situation. It's going to wind up repeating. And so this decimal is basically going to be 0.0454545 ... So it's asking for the digit. So if I take this number out and I write it out, 0.04545454545, and I count 28 places to the right, right? Usually a calculator only has a display for 7 or 8 places, right? Or maybe 9 places. But if you go 28 places out, what will the digit be in that slot? Okay, well, actually, I already know that it's going to be either a 4 or a 5, because this is going to be 4, 5, 4, 5, 4, 5, 4, 5 repeating. And that will be bigger than 1. So it's not equal, it's not less than, and we can definitely choose choice B. There's a slightly different way to get there as well, which kind of depends on your confidence with different decimals. So if you happen to know 1 over 11 is equal to 0.090909 repeating, technically you can get there just taking that dividing by 2 and get 0.0454545 repeating. That would also do it, but this is by sure the most certain way to do it. Okay, so a little bit about exponent, order of operations. So the rule is that you do anything in parentheses first. So like in this problem, you would do 1 plus 5 first and get your number 6, I guess. Then the next rule is you do exponents. So whatever you have raising something to a power, you do that next. So like 6 squared is 36. Multiplication and division occur at the same time. And they occur going from left to right if you need to do a tiebreaker. So here we can multiply times 2 and then divide by 12. So we get 72 divided by 12, which is 6. And I can actually write that faster, so let me do that. And then addition and subtraction also occur at the same time. So addition and subtraction you just conduct from left to right if you need to. So you can just take 6 plus 9 minus 8, and I'm not so smart, but 15 minus 8 looks like 7. And so that's the way you resolve the order of operations. One little note though, if you have a variable in the problem, whenever you substitute a number in for the variable, you can just automatically place parentheses around whatever you put in for the variable, and that'll maintain the order of operations if you start plugging in numbers. Okay. So some quick rules about about even and odd exponents. So specifically with even and odd numbers, with positive and negative numbers. So if you have a positive number raised to an even power, you get a positive answer. If you have a negative number, like -2, raised to an even power, you also get a positive number, right? And that's the fact, which is that any number raised to an even power is positive, except for 0, of course. If you have an odd exponent, it will keep the sign the same. So if I have something like 2 cubed, positive 2 cubed, the result will be a positive 8. And if you have something like a -2 cubed, the result will be a negative 8. So x to an odd power will keep the same sign as the x. Okay. Then there are rules for exponents. So if you have two different powers that have the same base, the base is the lower number, but different exponents, and you're multiplying, you can just add the exponents. So for instance, if I have 2 squared times, geez, Richard, let's just pretend that didn't happen. If you have 2 squared times 2 cubed, the result would just be 2 raised to the power that's the sum of those 2 exponents. So the 5 here comes from the sum of the 2 and the 3. And that's basically the rule here of m and n. This becomes n plus n. If you're dividing, so you need to have the same base. So I have 2, right, raised to the 3 power and 2 raised to the 2 power. Then you can subtract the exponents. So here the 1 comes from taking 3 minus 2, right, or m minus n. If you have a number that's a power raised to another power, then you actually multiply the exponents. So here I have 2 squared cubed. So the 6 comes from taking 2 times 3, or m times n. And then the last rule is negative exponents basically represent division by the same power. So 2 to the -2 power would represent 1 over 2 to the n. You can also kind of flop this rule around the other direction, which is if you take 1 over 2 to the -3, that would actually equal 2 to the +3. Right? So the idea is if you have a 1 divided by 1 over 2 cubed, when you divide by a fraction, you turn the fraction back upside down. So you actually wind up with 2 cubed up in the top. So this would be like 2 cubed over 1, for instance. And so these are all nice rules that you get when you're manipulating numbers that have the same base, but maybe different exponents. Okay. More tricks and traps, special powers for exponents involving 0 and 1, negative powers, fractional powers. Actually, we'll talk about this one in just a moment. But basically a fractional power, so something like, let's say 25 to the 1/2 power. The 1/2 power actually means the square root, and the square root of 25 is 5. So if you see something like 25 to the 1/2 power, it's definitely not 12.5, for instance, right? It doesn't mean that. What it means is you take the square root, and the square root of 25 is 5, of course. These we've already talked about. These we've already talked about. These we just talked about a minute ago. 0 and 1. Anything to the 0 power is 1. Yes. Anything to the 1 power is itself. And actually the negative exponents we've already talked about. And then every power of 0 is 0, except for 0 to the 0 power, which is not defined. One more rule. I missed it. We definitely need to talk about this rule for a second. This rule right here. So if you have two different bases, so the A and the B here are different, and you multiply them, you actually can write it this way. Actually going the other direction is more common. So it's more common that you might have something like 6 to the 4 power, and then you'll say, oh, that's equal to 2 times 3 to the 4 power. And then you can split that up as 2 to the 4 and 3 to the 4. Yeah. So this is a pretty typical move to make because 6 is not a prime number, but 2 and 3 are prime numbers, and it's nice to be able to factor that out and just be able to isolate the individual prime numbers. Okay. So example number 3, asking you for the value of this expression. I'll give you 90 seconds. Okay, so please enter your answer. So what do we got? So far it's around 75% for choice B, and then maybe 20% for choice C, roughly. Okay, well, I'm gonna make a little observation here just at the very beginning, and I'll come back to it much later after I've done a way harder calculation. But B is the only odd answer. All the other answers are even. Okay, that'll just be a little hint. So what do we need to do? Well, first of all, you really want to have the same number if you want to apply these exponent rules. So like here, 168 is kind of useless to us because it's not the same as 2, 3, and 7. So what I would do first is do a little factoring, figure out what the factors are of 168. You can factor it in different ways. I'd be tempted to factor out maybe a 4 first and get down to something like this, like 42. And then 4, you can factor as 2 and 2. You can stop here on the left side because obviously 2 is a prime number already. 42, you can factor as maybe 6 and 7. That looks pretty nice. 6, you can factor as 2 and 3, and you can stop. And 7 is actually also prime. So as it turns out, 168 is equal to 2 cubed times 3 to the 1 times 7 to the 1. Okay, so I'm going to hold on to that just for a moment. On top here, we're in pretty good shape already. 2 is a prime number, so there's no work to be done there. 7 is a prime number, so nothing to be done. 6 actually is not prime. I would encourage you guys to factor 6 as well. So if you look at the number 6 and factor it, actually this is a little bit overkill, but 6 you can factor as 2 times 3, or in other words, 6 is equal to 2 to the 1 times 3 to the 1. Usually when you talk about prime factors, You do include the 1 up here on the exponent, even though you wouldn't normally do that for most numbers, just to help you keep count of how many factors you have, right? How many prime factors you have. Okay, so let's put it all back together in the original calculation. So on top, we have 6 cubed. So 6 is 2 to the 1, 3 to the 1, and that's cubed. 7 to the 4, I don't have to do anything. 2 to the 6th, I don't have to do anything. On the bottom, we have 2 cubed. That's a 3, sorry. My pen hates 3s for some reason. 3 to the 1 and 7 to the 1. And then all of those are raised to the 3rd power. So this 3 here and this 3 here are the same 3. Okay, so then we can just apply our exponent rule. So this 3 here, we'll make this 2 to the 3, 3 to the 3, 7 to the 4, and then 2 to the 6. On the bottom, we're going to multiply the exponents. So I have a 3 exponent outside the parentheses. I'm going to multiply each of the exponents inside by that same factor, that same exponent of 3. So this will be 2 to the 9, 3 to the 3, and 7 to the 3. Okay, so now let me come back to this observation I made earlier about even and odd. And I'm going to do it by just focusing on these numbers here. So we have 2 to the 6 on the top here, 2 cubed on top here, and 2 to the 9th down here. So I'm just going to focus on this part and this part only. So what I'm going to find is that if I just look at powers of 2, on top, there's going to be 2 to the 9. Sorry, let me set up a little fraction bar here. So on top, I'm going to have 2 to the 9. And on the bottom, we'll have 2 to the 9. And there's going to be some other stuff here that I haven't actually written out yet. So just imagine there's going to be more numbers here, 3s and 7s and stuff. But already you can see that 2 to the 9 and 2 to the 9 are going to cancel out and just leave a 1. But then the other stuff here that I haven't finished writing down yet, the 3s and the 7s, are all going to be odd. So that means I already know that this final answer is going to be odd because I've gotten all of the 2s to cross out already. So I know it can't be A, C, D, or E. It must be choice B. B is the only odd number. Now, if you don't see that, or if you don't believe me, I can actually write out the rest of the calculation. So you have 3 to the 3 on top, 3 to the 3 on the bottom. Those will cancel out. You have 7 to the 4 on top, and 7 to the 3 on the bottom. So the rule here is you subtract the exponents. So you should get 7 to the 1. So that comes from the 4 minus 3. That's equal to 1 on the exponent. And there you go. That is the correct value, and choice B is the correct answer. So if you want to just go crazy and just go nuts and just do exponents all day long, you can do it. You can just write this all out and cancel everything out as you go along. But if you want to get more efficient for GRE, you want to start using the power of the 5 answer choices, and you need to start making observations like this, looking for little clues, like some of the answers are even, only one of them is odd, and start looking for that in these numbers earlier on, like will this be even or odd? And actually you can tell. You'll see that the even numbers are going to cancel out pretty early, and that means you can jump to that odd answer without having to do the entire calculation. Okay, so you know the rules, you know the properties, but then you don't do everything in the problem. You just focus on the relevant part that helps you make the decision about which answer choice is the correct answer. And that's really what good strategy is all about for GRE. Okay, question about that one? Okay, let's do a quantitative comparison example. So again, just as a reminder, choice A means that A is always greater than B. B means that B is always greater than A. C means that A and B are always equal. And D means that they are sometimes greater, sometimes equal, sometimes less. Okay, I'll give you 90 seconds. Okay. So please go ahead and enter your final answer. It looks kind of divided, actually. I would say maybe it's about 60% for choice D and about maybe 40% for choice B. And actually, there's been a few A's in here as well. Yeah, maybe 20% for A or something. It's not 100%, but you get the idea. Well, of the four choices, A, B, C, D, the one answer that it cannot be is C. And this might be a kind of a weird point, but there's no way that they can be equal. And the answer is, if I have 2 to some power, it doesn't matter what the power is, and I have 3 to some other power like this, they can never be equal because they're different prime numbers. As long as A and B are not equal to 0, this could never be equal. So that's one kind of point. Second thing is, if you want to decide whether it's A or B, remember that having A be bigger than B for, like, say, for choice A, it's not good enough to have it be sometimes bigger. It has to always be bigger, right? If you can make the relationship change, then you have to pick choice D. But in order to see if you can make the relationship change, you have to plug in at least twice, right? So now we're told that X is a negative integer. So it has to be something like this, like -1, -2, -3, -4, ... We have pretty much an infinite number of possible candidates there. As an easy choice, I would start with plugging in X equals -1. This is the extreme case. It's where you're most likely to catch a transition. So if we look at the left side, we're going to get 2 to the -2 power. Negative exponents means we take the fraction of that, the reciprocal of that. And actually, I'm going to calculate this number because we need to know the value. So 1/2 squared is 1/4, and that's about 1.25. Now, for this side, if I put X equals -1, this will be 3 to the -1 power, and that'll be about 1/3. And not about, exactly 1/3. So which one is bigger? At this point, 1/3 is bigger than 1/4. So it looks like it's choice B. And that means we definitely know it's not choice A or choice C if you haven't already crossed it out. But it doesn't always have to be that way. So for instance, we need to test whether it's always this way or whether we can make a change. Go to the next number, try X equals -2. So when you take a smaller, when you divide by a bigger number, you get a smaller result. Yeah, so because 4 is bigger than 3, 1/4 is smaller than 1/3. Yeah. Okay, so it looks like someone just changed their answer. Okay, so we're gonna plug in -2. So you gotta make sure on this type of question, you have to plug in at least twice because you have to give yourself the chance to see how things might change as X changes. So plug in X equals -2, then we've got 2 to the -3 power. That's equal to 1/2 cubed, and that's equal to 1/8. Okay, hold that thought. Over here, we're gonna have 3 to the -2 power. That's 1/3 squared. That's 1/9. So again, the rule is when you divide by a bigger number, you get a smaller result. So now the right side is smaller and the left side is bigger. So this one seems like it's choice A, but it isn't because it's not always A. And so here's a classic example of where choice D is the correct answer. Sometimes B is bigger, sometimes A is bigger. That's why you need to choose choice D. You are able to make a change by changing the variable. Yes. Yes, someone in fact did change their answer. I noticed that. Good for you. It's always good to be on the right side of history. Okay. A little bit more about exponents and roots. So just again, a reminder that a fractional exponent means a root. So if you have something like this. Something like 32, the square root of 32. Well, this is actually equal to 2 to the 5th power in the square root. But we can convert this to a fractional exponent that looks like this. So the numerator here, the 5, represents taking 2 to the 5th power. The denominator here of 2 represents taking the square root. And then the thing is, you actually can change the order of this if you want to. So you can take the square root of 2 and raise that to the 5th power. That's equal to this over here. So let me switch colors just so it's a little bit more clear. But basically the rule is, if you have both a root and an exponent, you can do the exponent first on the inside and then do the root later on the outside. Or you can do the root earlier on the inside and then do the exponent later on the outside. You'll get the same result either way. It's still 2 to the 5 divided by 2 power. Okay. So fractional exponents mean that you're doing two things. You're doing both a root and an exponent. Okay. So this question is giving you a fact. It says that P is between 0 and 1. So let me just draw that on the number line real quick. So, whoops. So our number P, we don't know the value of P, but it's got to be somewhere between 0 and 1. And they're asking you which expression has the minimum value. So of the 5 answer choices, which one's actually going to be the smallest? Okay. And I'll give you 90 seconds. Good luck. Okay, so please put your answer in the question box. So I have C, A, E, B, C, A. Okay, got quite a wide range actually. Well, the correct answer is B, boy. And there's several different ways you can approach this. I'm going to show you using the number line first, then I'm going to come back and plug in and do it with a calculation to back that up in case you don't believe me. But I'm going to try using the number line first. So first of all, any number that is raised to the 1 power is itself. So we can write this as P to the 1 power. Now because P is between 0 and 1, when you take P squared, P squared will be smaller than P, right? Because P is smaller than 1, when you multiply by itself again, you're going to wind up getting a smaller number. That's actually going to be here. P to the 1/2 is the square root of p. Now, actually, the square root of p is going to wind up being over here. It's going to wind up being it's going to be bigger than p. So normally when you take a square root, like at the square root of 25, it gets smaller because it's equal to 5. But another way of saying it is that when you take a square root, the number gets closer to 1. So when you take a square root of a number between 0 and 1, the square root actually gets closer to 1. So it's actually going to be a bigger value. P to the negative 1/2. So this will be 1 over p to the 1/2, which is 1 over the square root of p. So this is the reciprocal of that number. So when you have a number that's less than 1 and you take the reciprocal winds up being a bigger number. A number bigger than 1. So it turns out that p to the minus 1/2 will be even bigger. Then this guy, p to the 3/2 power, is going to be p cubed and then the square root. You can do that in either order. But in terms of where it goes in the number line, I can tell you that because 3 over 2 is between 1 and 2, right? Like 1.5 is between 1 and 2. The value of p to the 3/2 power will be somewhere in here. So if I put the different choices in order, here's A, here's B, here's C, here's D, and here's E. Which one's the minimum value? The minimum is this one. Okay. So I think that this is ultimately the most powerful approach if you understand the number line and you understand what those exponents are doing to the values. The trouble is that you got to have a lot of confidence in yourself to know that it's going to work that way. So the backup plan is to plug in. And yeah, so when you have a negative, so someone's asking about this one, about the negative 1/2. Yeah. So if you have the negative exponent, it's 1 over that value. Of course, it's a square root, so it's 1 over this. So like if I want to take as a simple example, like if A was equal to when you take the reciprocal of a number, which is what happens when you take 1 over that number, I mean, compare something like this, like 1/2 versus 2, right? So when you take a number and turn it upside down, if the original number was less than 1, the new number will be bigger than 1. And vice versa. If the original number was bigger than 1, if you take the reciprocal, the new number will be less than 1. So when you divide by 1 like this, it basically means you're turning the fraction upside down. So let me do this again with a plugin, and maybe you'll see it a slightly different way. So I'm going to pick a value for p. I'm going to pick p is equal to 1/4. And I'll just do calculations for all of these. So A, the square root of 1/4 is the square root, well, it's actually just 1/2. So notice the square root of 4 is equal to 2. So the square root of 1 over 4 is equal to the square root of 1 over 2. P squared. If I take 1 over 4 squared, I'll get 1 over 16. That was actually the correct answer. If you guys remember, B is supposed to be the smallest value. C, so it's 1/4 to the negative 1/2 power, right? So that's 1 over the square root of 1/4, which means it's 1 over 1/2, which is equal to, don't do this to me now. Okay, we got enough space at the edge of the screen, awesome. So 1 over 1/2 is equal to 2. So the rule is when you're dividing by a fraction, you flip the fraction upside down. And that one actually turns out to be the biggest. For D, if you have 1/4 to the 3 over 2 power, that means you're going to take the square root of 1/4 cubed. So remember, you're allowed to do the root first or the power, and then the root. Either way is fine. So I already know the square root of 1/4. That's from choice A. So that's 1/2. And then we'll have that cubed. And if you cube that, it's 1/8. So 1/8 is actually a fairly small value, but it's less than 1/16. I'll clean this all up in just a minute. And then P is just the original number, it's 1/4. So I'll just make a list of the different values and show you where they are. So for A, we got 1/2. For B, we got 1/16. For C, we got 2. For D, we got 1/8. And for E, we got 1/4. So if you look at these numbers on the number line, we're going to have something like A here, B here, C here, D here, and E here. And B is the smallest. Okay. I think if you get the actual, if you understand the relationship that when you take a fraction squared, it gets smaller, as long as you understand that relationship, you should be fine on this question. But you know, if it's not clear, if you're not seeing it from the 5 choices, go ahead and plug in a value. You can do the calculations and everything should turn out fine. You can also do this calculation using decimals. It's a little bit harder. And I'm not going to get into it now, but it's definitely possible to do this with fractions if you want. Sorry, decimals if you want. My suggestion would be, if you're going to try decimals, pick something like this. Pick P is equal to 0.49 or 0.50. So when you want to take the square root, you want to take the square root of 0.49 because at 49, the square root of 49 is 7. 0.50, you can also square that and get 0.25. So I would pick a decimal like this where you can kind of estimate it a little bit or adjust the value as needed for the problem. But that's a little bit harder. I would stick with the fractions. Okay. Yeah, okay, so this is another issue. So so this really is the key issue, which is that P has to be between 0 and 1. So like, what happens if you don't do that? So like, maybe we'll go to 8 or something like that. So yeah, I mean, you could mess up and you could do something like this. You could say x equals 2, right? Yeah, so what happens when we take x squared? Well, x squared is bigger. X squared is equal to 4, right? And what happens when we take the square root of x? The square root of x is equal to about 1.4 or so, somewhere in this neighborhood. And then if you want 1 over the square root of something like this, so 1 over the square root of 2 is something like 0.7. That would be the smallest. And I'm missing one other one, p to the 3/2 power. I don't know the value off the top of my head, but it's probably about 2.8. Yeah, so basically the relationship would be running the other direction. Yeah. Okay, I don't know this exactly 2.8. I'm estimating from memory, but basically the idea is for a number, if you pick a number bigger than 1, then what happens is when you square it, the number gets bigger, right? And when you take the square root, the number gets smaller. That's the normal relationship. But this problem's not about that type of number. This problem's about p. P is between 0 and 1. So we do need to move on, but I think because it is the key point of the question, let me just reiterate one more time. So if you pick a number here between 0 and 1, if you square that number, it gets smaller. If you take the square root of that number, it gets bigger. On the other hand, if you have a number that's bigger than 1, when you square it, it gets bigger. And when you take the square root, it gets smaller. So yeah, definitely it's the exact opposite direction. And that's really what they're testing on this question. If you're just looking at the numbers, it really should be either B or C. It's got to be one of the extreme values. If there's a number like X, the correct answer would be C. If it's a number like Y, the correct answer would be B. and it was B. Yeah, so I think once you get this like mental picture in your head, these types of problems become a lot easier, and you can cut down on the plugging in. Okay. Equations that have exponents with variables. Okay, questions like this. So we have x in a weird place. So we have x in the variable, right? This is actually a solvable type of equation, but not the way that you might think. So what you need to do is you need to get the same base on both sides of the equation. So for instance, 81 is equal to 3 to the 4th power. If you don't know that or don't have that memorized, you definitely can work it out really quickly. 3 squared is 9, 3 cubed is 27, and 3 to the 4th is 81. Okay. So you definitely want to have the same number in both places, the same base. So remember, the base means the bottom number. So 3 to the negative 4x and 3 to the 4. Once you know that, if the bases are the same, then you can say that the exponents are the same. So we can just say that negative 4x is equal to 4. Now we can just solve for x. And so x would equal negative 1. But you're only allowed to do this trick if you have the same base on both sides of the equation. Okay, now, let me just add one more wrinkle to this before I go on. If you want to have the same base, it's better to make it a prime number. Because prime numbers have a unique prime factorization, you're guaranteed to get the same exponent, and it's guaranteed to have a unique answer if you focus on the prime bases. You can do it with numbers like 4 and 8 and 16 sometimes, but generally speaking, it's better if you break that down to 2, because 2 is the prime number, and that means you're guaranteed to get the same exponent everywhere. Okay, with that in mind, so here we have an equation that has a variable in the exponent. So I have z in the exponent here, and they're asking for the value of z. So just as a little hint, notice that 4 is not prime, 6 is not prime. Okay, that's a little bit of an obstacle for you guys on this problem. What you want to do is you want to break this down to the prime factors and then compare the exponents. Okay, so you have 90 seconds. Yes, 90 seconds. Okay. Yeah, please put your answer in the question box. All right, so it looks like the majority is going for choice A. You got a couple straight answers. A is the correct answer. So A is correct. Z will equal 23. And I'm gonna show you kind of a bigger calculation than necessary, and then I'll come back and show you how you can really identify and isolate the relevant part of this. So when you look at the 4 here, 4 is equal to 2 squared. We're gonna raise that to the 12th power. 3 is a prime number, so there's no change there. 2, we're gonna add a 1, just because we always wanna keep track of our exponents. It's not redundant, we're actually gonna put the 1 there. 6 is equal to 2 times 3. Specifically 2 to the 1 and 3 to the 1, and we're raising that to the z power. Okay, so I'm gonna simplify the left side a little bit, have 2 to the 24 and 3 to the 23. On the right side, we're gonna have 2 to the 1, 2 to the z, and 3 to the z. So remember, we have an exponent outside the parentheses. You multiply the exponents inside the parentheses. So we'll have 2 to the 1, 2 to the z, 3 to the z. And I'm actually gonna, I'll go one more step. So this is 2 to the 24, 3 to the 23, 2 to the z plus 1. So remember, when you multiply numbers with the same base, you add their exponents. So 1 and z is equal to z plus 1. And then 3 to the z will just stay there. Nothing's going to change there. Okay, so what is the rule? So the rule is that when you have prime numbers, that the exponents for each prime number has to be the same. So if I look at this pink box on the left side and the pink box on the right side, those have to be equal, right? Because 2 is prime. There's no other way for them to be equal, right? So based on that, for instance, I would know that 24 is equal to z plus 1, right? And you can solve that for z. Now let me switch colors here just to make it clear that it's separate. However, it is also true that 3 is a prime number. So this green box on the left and this green box on the right also have to be equal. Right? So that gives me a different equation for z, that 23 is equal to z. Now, I know it's not a big deal, but you don't need to solve both of these equations for z, because z can only have one value, right? If you do solve the first one, the one in pink, you would have to subtract 1, and z is equal to 23, and that is correct. On the other hand, with the green equation, you don't have to do any work at all. You already see that z is equal to 3. Now, let me just back up a few steps. So notice that once you see this, the things that happen to the 2 and the things that happen to the 3 are really kind of separate from each other. So if I start walking backwards through my equations, let me look at this green box on the left side and the green box on the right side. So this one step earlier, which is where I really wanted to stop, but the teacher and me forced myself to keep going. You can see that the 23 here and the z here are already going to be equal. So you would already know that this equation is 23 equals to z. But actually, you can even back up one step further. If you go to here, you can see that you have a 23 on the left. And here, you're going to have a z on the outside and then a 3 to the 1 on the inside. And so you know that z has to equal 23. It's the only way that can happen. 1 times z is equal to 23. If you're really good, you back up all the way to the original equation and you say to yourself, well, this is 3 to the 23 here, and this has got a z in it, and there's going to be one number of 3 inside of this, and you can actually, from this original equation, pull this out and see that 23 is equal to z, and never mess around with all the different powers of 2. And that's really where, the power of understanding the concepts comes in, is that you can look at that exponent on the 2s, or you can look at the exponents on the 3s, and it's really something you can separate and isolate, and you can just pick the one that's the easiest for you to calculate. Yes. Cool. All right, let's go to a quantitative comparison alternative of this. Okay, so again, as a reminder, A means that A is always bigger. B means that B is always bigger. C means that A and B are always equal. D if they can change. Okay, last chance to put your answer in the question box. And it looks like we're about maybe 60, 70% for choice B, and about 20% for A, no, 20% for C, maybe. Okay. Yeah, all right, well, let me, so the correct answer is choice C. I'll tell you that now. So at the very beginning of the question, realize that there's no chance for D to be the correct answer. And the reason is there's no variables in the problem. So whatever these numbers are, they're numbers. They're either bigger, smaller, or equal, but they can never change, right? So D can't be the correct answer. Now the left side's a little bit harder. I'm gonna have to mess with this part first. So when you have 3 to the 22 minus 3 to the 21, you can write this as 3 to the 21 times 3 to the 1 minus 1. Okay, and I'm gonna divide by 3 again because that's part of it. So let me put that back in. But what that means is you're gonna wind up with something like this: 3 to the 21 times 2 divided by 3. And actually, I'll put a 1 on that just because we want to keep track of our exponents. So 3 to the 21 minus 3 to the, divided by 3 to the 1. We subtract the exponents, we get 3 to the 20. And of course, all this is equal to 2. So just in case you missed it, the 2 comes from the fact that inside the parentheses, I have 3 minus 1. Okay. And so that's our value on the left side. What's the value on the right side? Well, actually, when you add two numbers together, this is no trick. It's just equal to 2 times that number. Right? And so what you have on the right side and what you have on the left side are actually the same. They're equal. And C is the correct answer. So the thing to realize is when you have addition or subtraction, there's no nice quick rule to do it. What you have to do is you have to factor out. That's usually what this is called. You have to factor out the biggest piece that you can, which will be the one that has the smaller exponent. Okay. So it looks like we're getting near the end of the time. I do want to leave some time for the Q&A session. So just so the recap and takeaways. So 2 main levels of thinking here. So number 1 is you got to know the rules. You got to know them cold. So you got to understand the basics of addition, subtraction, multiplication, division, powers, exponents, and also some special tricks for 1, 0, fractional exponents, negative exponents. You have to know all those rules and be able to use them well, right? Second level, of course, is the reasoning process, right? So understanding that not every part of the calculation will be useful. Try to isolate the part of the calculation that is going to be relevant and will help you make a decision. They'll let you choose the correct answer choice, and try to use your strategy effectively to pick the correct answer in the time that you have, the time limit that you have. So I'm going to stop here, I think. And let the Q&A get started. Do I need to make someone else the presenter? Okay. All right, guys. Well, thanks so much for being here and all of your participation. I really enjoyed it. And I'll be hanging around in the background while you guys are doing the Q&A too. So good luck.